Hi guys, welcome to video 2 of our CSWA exam preparation series. We are going to be covering questions 3 and 4 of the sample exam in this video. I have the sample exam PDF open on my screen. I encourage you to read the questions carefully. The modeling questions will give you some orthogonal views such as top, front, right, isometric, or any additional views that you need. These views are giving you an idea of how to build the part. Looking at the PDF, there are a couple of things that stand out to me. Number one, there are letters A, B, and C. This automatically tells me that we will be making some simple global variables or equations. Number two is the chamfers. There are 3 chamfer dimensions that are provided. You can do the chamfers in the original sketch, but a key to success with these exams is keeping your parts organized and your sketches simple. I am going to exclude the chamfer dimensions from my sketch in order to save some time, but to also simplify my sketch. Scrolling down, the questions we see are provided are units, precision, design intent, material, and the values for A, B, and C. We are asked for the mass of the part in grams. Knowing this information, we're ready to get started with our model. Once inside of Solidworks, the first thing that I'm going to do is access my millimeter part template. This is going to pre-populate my units for me. Now, if you don't have a template that is already specified to millimeters, you can change or verify your units in the bottom right-hand corner. So we want to make sure we're on millimeter grams second. The second thing I'm going to do is make sure my equations are accessible. If you don't see yours on the command manager, you can always access them under Tools, Equations, or you can go in your search bar, search via commands, and find your equations item there. From here, you can launch it or drag it onto your command manager for use throughout the exam. Once my equations dialog screen has been launched, I'm going to start entering my ABC global variables. So based on the PDF, A is going to be 81. My global variable B is going to be 57. And then my global variable C is going to be 43. With these specified, I have all of my setup done and I'm ready to start with my actual sketching and modeling. I'm going to go ahead and choose my front plane, and I'm going to open up a brand new sketch on the front plane. So I chose the front plane based on the views that they provided me in the PDF. Let's review what we're actually going to be sketching. So this is what SolidWorks has provided for us. There's a couple of things that we want to take a good look at, including the tangent relationships that they've specified. So the bottom tangent is a tangent between 2 arcs, and the tangent at the top is between the 19 radius arc and an angled line. So we want to make sure that we have those items inside of our sketch. The other item is the center of the 29 millimeter radius arc is going to be coincident to the angled line that's in the bottom left-hand corner. So let's go back into our sketch. I'm going to create my origin over on the left side, and I'm going to start in my line tool. I'm going to use my shortcut to go from a line into a tangent arc, and you can do that between arcs as well. That keeps me inside of my line tool and can shave off some time while I'm sketching. Now this top arc is not a tangent arc, so I'm going to use my 3-point arc, just estimate about what the size is going to be. We're going to add dimensions later. Go ahead and feel free to use shortcuts. I just use my mouse gestures, and then from here I can drag that line up to the top. The shading is going to tell us that this is a closed sketch, which is good because none of our corners are going to be open. So from here, we need to start adding some of our dimensions. I'm going to start with my larger overall dimensions first. So this first dimension is going to be linked into global variable A. This was one reason why we started specifying those global variables. My overall height is going to be linked into global variable B. So I'm doing this by clicking the equal sign in my modify box to bring up my global variables. From here, we want to start moving around our model to add the rest of our remaining dimensions. So I'm going to add my 32 millimeter height dimension over on the left side. we want to make sure that this top line is going to be 14. I'm going to add my angle dimension and change that to 10. And I'm going to specify my 19 radius dimension. It's going to change the size of my arc. I want this additional top line to be 29. And then the height of the right side to be 24. This larger radius is going to be 29 millimeters. Now here I have to get out of my Smart Dimension tool and I need to manually add this sketch relation. So this sketch relation is between the center of the arc and the line. If you see the overlap like I just did, remember that any blue vertex can be pulled and dragged to fix that issue. And the height of that center point of the arc is going to be 19. That's what that dimension is actually referencing. So I want to add my dimension for the smaller radius, which is going to be 5. I need the height from the bottom to my lower edge on the left. That's going to be 19. And my remaining dimension is going to establish the last distance, which is going to be 29. So when I zoom out, my sketch is fully defined. Everything is black. I have all my dimensions and sketch relations. So let's go ahead and extrude this. Now the extrusion for this doesn't really matter whether it's blind or mid-plane. I'm going to then link this into my global variable C, so we can add global variables directly into our features. This gives me the basis for my part. I still have some additional items I need to add, such as the hole. Now you could use the hole wizard for this. Doesn't specify that we have to do that, so just for speed, I'm sketching it manually. And these dimensions, of course, are coming from the PDF. Again, we want to make sure that sketch is defined, and then I can cut this. I'm going to use through all. That's going to reduce editing that I have to do later if I have to make changes to it. And then, as I mentioned previously, I'm going to go into my chamfer tool. So the first set of chamfers I'm going to add are going to be my 7mm chamfers. Again, the reason why I did this is because there's a lot less information I have to add into my sketch, and I will be making modifications to this in the future questions. So this is a great way to really stabilize and reduce any problems there. So we're looking pretty good based on the PDF. I still have to add my materials. So I'm going to add my AISI 1020 steel. And from here I can go under my Evaluate tab and go under Mass Properties. And we can see that my mass is equaling what is inside the answer key in the document. So I'm spot on, and we're ready to go on to the next question. So part 4, or question 4, doesn't have us do a really large change, but A, B, and C do need to be updated to those respective values. So this is going to be a pretty simple change. Because we utilized our equations, I can go back into my equations dialog box and simply update my values. So A is going to update to 84, B will update to 59, and C will update to 45. Because we're working inside of equations, my model's already rebuilt with those minor changes. So I can go under my Evaluate tab, get my new mass, which again, if we compare it to the answer key that was provided for us in the PDF, I'm spot on. So I know that my answers so far have been correct. So that will put us in really good shape for the next section, where we're going to make some more substantial changes to the model. So I'll see you in the next video. Thanks.